All right, so we're armed with all the formulas we need to do useful stuff. Let's make a quick estimation of how big the Debye screening length typically is. So I'll use an example of sodium chloride. So if I put, I don't know, zero point zero 0.01 molar sodium chloride into water, what does that screening length look like? Well, let's do a little bit of conversion first. So if I'm using molarity, I need to convert moles per liter into number of atoms per meter cubed. So if I do a little bit of magicianry here and normalize, using Avogadro's number and the definition of a liter, then we can get the number density of sodium ions in the bulk anyway, which turns out to be 6 times e to the 24 per meter cubed, and the number of chlorine ions will be exactly the same because it's charge neutral. And the relative permittivity of water is 80. The universal, the permittivity of a vacuum is 8.85 e to the minus 12 farads per meter. So then, using that, we can calculate the Debye screening length. Basically you just plug in the formula. So in the case of sodium and chlorine, both of those only carry 1 unit of charge each. That would be different if you were using things like magnesium, which carry 2, for example. So anyway, you plug in the numbers, using all the universal constants that are available. I'll set the temperature to room temperature, which I guess is what we're interested in, and then basically work out the math. If you work out the math, this works out to be something on the order of 3 nanometers, which is pretty typical. So if you look, depending on whether you have a highly concentrated salt or whether you have a very low concentration of stuff, you can get Debye screening lengths in water that are anywhere from less than a nanometer up to hundreds of nanometers if you have a very dilute solution of something. But those are kind of the typical ranges. And they're mostly determined by 2 things. One is, what is the number density, or, what's the ionic concentration you're going to use. But it also depends on what the fluid is and what the relative permittivity is. And that varies quite widely from fluid to fluid as well. But that's sort of a typical range.